So we are now calculating entropy of fusion, entropy of vaporization and entropy of sublimation. So as the process says, for example, entropy change in the process of vaporization, what will happen? Liquid will convert into vapors. Alright. So if you see, the change will be entropy of vapors minus entropy of liquid, right? For that, we have a basic formula that says delta S at boiling point will be enthalpy of vaporization upon boiling temperature or boiling point, whatever you call that. So entropy change in a vaporization process can be calculated like this. Similarly, entropy change during melting you can calculate like this. Enthalpy of fusion, we call that energy change or enthalpy change during a process of melting, means solid to liquid conversion is there. If you want, you can do entropy of liquid minus entropy of solid. That means final state minus initial state. And direct formula says enthalpy of fusion upon melting point will give you entropy change during melting. Alright. Next we have enthalpy during sublimation. What is that? We have enthalpy of sublimation upon the temperature at which sublimation is happening. So using these formulas you can calculate easily entropy change during any physical change. Physical change, that is change in the physical state. Next we have second law of thermodynamics. What does it say? This law says that for a spontaneous process the entropy change of the universe is positive. That means in a spontaneous irreversible chain, entropy of the universe keeps on increasing always. Another way you can say, it is not possible to construct 100% efficiency Carnot engine, or there is another way to say this as that 100% conversion of one form of energy into another form is rarely possible, right? So these are few statements which have been used for explanation of second law of thermodynamics. Same way we can say we cannot prepare a machine, construct a machine which has 100% efficiency. There will be some energy loss always, right? So that is what has been explained over here. All forms of energy can be converted into heat, but heat cannot be converted into other forms of energy fully by any process. That is why we say that 100% conversion of one form of energy into another is hardly possible, right? So that is what has been explained. And in terms of entropy, in an irreversible process which is a spontaneous process is the one which is happening on its own, like falling of this pen. This is a spontaneous process. So in a spontaneous process, entropy of the universe will always keeps on increasing. Delta S universe is positive. That is what second law of thermodynamics is all about. And last but not the least, it is very important, Gibbs free energy change. What Gibbs free energy change is all about? So if a thermodynamic process is happening, what do you think? Do we have control over that? Can we use all the energy produced during that process in doing work? Not at all. Some part of energy is used up in increasing entropy of the system. Some part of energy is transferred, but some part of energy we can use for doing certain work. So the useful work obtained during a process, the useful work obtained during a process is known as Gibbs free energy change, that is represented as delta G. As we represented entropy change delta S, entropy change by delta S. Similarly, we have Gibbs free energy change which is represented by delta G. So we have a formula for delta G calculations, that is delta G equals to delta H minus T delta S. This relation is known as Gibbs-Helmholtz equation, and we have been using it time and again. Alright. So that is what has been explained over here. And for enthalpy we have already studied delta H equals to delta U plus P delta V, or delta H equals to delta U plus delta NGRT. You can use whichever is required in a given problem and you can calculate everything fine. That's it.